Something escaped a black hole at almost the speed of light, and NASA recorded it. Captured at the Chandra X-ray Observatory Center in collaboration with the Harvard-Smithsonian Center for Astrophysics, a system with a black hole and companion star about 10,000 light-years from Earth was caught by astronomers. They have captured a stellar mass black hole hurling hot material into space at close to the speed of light, using 4 Chandra observations in 2018 and 2019. Upon hearing that a black hole is spewing out material instead of sucking it all up, one might stand in a puddle of confusion. It begs one to ponder that perhaps they've located a white hole instead of a black hole. White holes are theoretical cosmic regions that function in the opposite way to black holes. Just as nothing can escape a black hole, nothing can enter a white hole. Truth be told, white holes were long thought to be a figment of general relativity born from the same equations as their collapsed star brethren, black holes. More recently, however, some theorists have been surmising that these twin vortices of space-time may be 2 sides of the same coin. To get a better understanding, let's tune in to theoretical physicist at the Centre de Physique Théorique in France, Carlo Rovelli. He asked audiences to imagine floating in space in a high-tech spacecraft observing space. From afar, a white hole looks exactly like a black hole. It has mass. It might spin. A ring of dust and gas could gather around the event horizon. And just as usual, the bubble boundary of the black hole separates the object from the rest of the universe. But if the space travelers kept observing, they'd eventually realize the supposed black hole give a hearty belch. Carlo Rovelli says, "It's only in the moment when things come out that you can say, ah, this is a white hole." So when the Chandra X-ray Observatory Center framed graphic, optical, and infrared images of the space area called MAXI J1820 plus 070, and data revealed that 2 jets pointed in opposite directions, launched just outside the event horizon of a black hole, shock spread across the field. Here are the details of this shocking find. Here's the vital notes of the eternal mysteries of space. Here's the best place to learn about the infinities of space. Welcome back to Space Infinity. Follow the takeoff protocol for a new journey. Like, subscribe, ring the notification bell, and share this video. Call it what you want, but debris, material, or substances are blasting away from the black hole at about 80% of the speed of light. In technical terms, the scale on the optical infrared image showed about 44.5 degrees, or 8,000 light-years across. The X-ray inset image showed about 30 arcsec, which is about 5 light-years across. In layman terms for the concrete learners just trying to get a solid foundation of understanding, the Chandra X-ray Observatory ACIS image is the black hole in the MAXI J1820 plus 070 system that has a mass around 8 times that of Earth's Sun. The photo indicates that it is a stellar-sized black hole formed by the collapse of a massive star. It's not fair to call it supermassive black hole because most observed supermassive black holes have millions or billions of times the mass of our Sun. Nonetheless, its bizarre behavior with its companion star mesmerizes us Earthlings. The companion star orbiting the black hole has almost the same mass as the Sun. The immense gravity of the black hole drags the companion star's material toward the black hole's center. With the X-ray producing disk bringing over material to the event horizon, it's astonishing to see the immense gravity of the black hole dragging the companion star's energy inward. While some of the heated gas in the disk will reach the event horizon and fall into the black hole, some of it will be ejected in a number of brief beams of jets from the black hole. These jets are released along magnetic field lines from beyond the event horizon and aim in opposite directions. Observations of deep space. Chandra's 4 observations in November 2018 and February, May, and June of 2019 showed a new picture of the black hole's activities. It was discovered in the astrophysical journal Letters by Matilda Espinosa of the University of Paris in a study. He vouched that the images indeed show a massive optical and infrared view of the Milky Way galaxy, captured by Hawaii's Pan-STARRS optical telescope, which was aimed at MAXI J1820 plus 070. The details indicated that super-speed jet streams of particles were indeed shooting off from the north and south magnetic streams of the black hole. In the May and June 2019 measurements, the southern jet was too faint to be identified, yet its brightness today sheds more light, through the light years. Pun is definitely intended, and the literal sense is spot on in the infinities of space. Black hole crumbs. Since we know that a black hole's primary objective is to eat up everything in a mysterious dark abyss, It's quite a shock to see how fast material belches from a black hole. From Earth's perspective, the northern jet appears to be traveling at 60% the speed of light, while the southern jet appears to be traveling faster than the speed of light. Red flags must be going up in your brain. Something sounds definitely wrong. How can anything move faster than light? The thought sounds preposterous. After all, nothing can move faster than the speed of light, right? Right. This rare phenomenon is an example of superluminal motion, which occurs when an object approaches us at almost the speed of light and in a direction parallel to our line of sight. This means that the light approaches us nearly as quickly as the light it emits. Consequently, this gives the impression that the black hole emission is flying faster than the speed of light. However, measurements show that while staring at the MAXI J1820 plus 070's south jet, which is heading in our direction, the north jet is facing away, while measurements show that this indicates that the south is traveling more quickly than the north. According to Chandra's records, only 2 previous instances of such fast X-ray ejections from a stellar mass black hole have been recorded. Shocking records for a black hole. But a white hole remains the uncommon brother of the black hole, and it's expected that we delve into the mysterious space entity. The white hole. The white hole is shocking to many, and that's why it's essential to expound on it. Physicists describe it as a black hole's time reversal. It's considered a video of a black hole played backwards. It's often described as a reflection of the reverse of a bouncing ball. It's even been contributed to time reversal itself. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission. It is space-time's most exclusive club. No spacecraft can ever reach the region's edge. Objects inside a white hole can leave and interact with the outside world, but since nothing can get in, the interior is cut off from the universe's past. No outside event will ever affect the inside. According to black hole pioneer and professor emeritus at the University of Washington, somehow it's more disturbing to have a singularity in the past that can affect everything in the outside world. And Ravelli admitted that it took 40 years to understand black holes, and it's only recently that people have been focusing on white holes. It's the theoretical twin. Einstein's field equations hit physics like a typhoon in 1915, and theorists are still sorting through the wreckage. Beyond describing the force of gravity, Einstein's hypothesis also brought a paradigm-shattering message about the nature of reality. More than a rigid backdrop, space and time bend and fold along with the mass of stars and planets. That insight sparked a race to calculate just how much abuse space could take from the matter that drifts through it. Within a year, physicist and astronomer Carl Schwarzschild found the first exact solution to Einstein's equations, calculating how space-time curves around a single ball of mass. In his answer lay the seeds of what physicists today call a singularity. You'll remember this phenomenon from studying the Big Bang. It's a spherical mass shrunken down to an infinitely dense point, wrapping space around it so tightly that the region pinches off from the rest of the universe. It forms a no man's land whose event horizon fractures the link between cause and effect. Yet there are holes in space. After that singularity and Big Bang, there's black holes. And down the plug hole, everything from matter to light falls towards the singularity because of the dent in space-time. Theoretically, we'll run into wormholes in which some believe that a black hole could possibly form the entrance to a wormhole. It's in that wormhole where scientists predict time travel is possible. At the wormhole's exit, matter and light are thrown back out of a white hole. Space is eternal, and Space Infinity will keep you updated and informed. Be sure to smack that like button, subscribe, ring the notification bell, and share this video. For more, be sure to click on these videos to lead you directly to the Space Infinity Archive.